Hey guys, this is Civil Bro Mainak, and this is another blog on a particular design and Tekla structural designer. So if you want my free course, certified course for building design using Tekla structural designer for the IS code, simply just knowing the all the procedures, you can check out the link to the in my description. I have a course on Udemy. It's free for all. You can complete the course and get certified and use it to boost your career. Okay. So we'll start today's blog for the particular building design. It's a building, and this is the building area. Only ground floor is being constructed, but I'm going to give the loads for let's say another more floor. So suppose in case in future they want to make another more floor. So it's a very small building. I'll just I've only already made the DXF file. The center line is in a separate layer in AutoCAD as we always need to do, and the others are in a separate layer. Okay. So first of all, we import the DXF file, and before that also we'll make the levels. So we go to model, we go to construction levels, and we'll create the levels. So this will create a bottom level. So let's take a plinth height of, let's say, suppose 1.2 meter, right? So 1.2 meter, if you know, it's approximately equals to 4 feet. So let's take plinth height of, let's say, 1 meter. Okay, 1 meter, 3.28, 3.3 feet. So this is common. So 1 meter and foundation depth of 1.5 meters. So it becomes 1 plus 1.5, that is 2.5, right? So here in this we'll write minus 2.5 meter. And this is the uh, you know this is the plinth level we are taking as the plinth level, and this we are taking as the foundation level. So difference between the foundation level is equals to the depth of the foundation plus the height of the plinth. So minus 2.5 will be taken here, and then we'll take insert another floor here, and this will be our let's say this will be our next ground floor. So here we'll just do here SSL. So SSL means your structural slab level, and TOF means T top of foundation or troubleshooting. So this will be this thing. Okay, this is like one error has just cancel this. There is one error. So this is the base, this is zero. I'll consider this a plinth level. Insert below, and here let's minus, not here. Here this spacing will be let's say 2.5. Okay. This is, let's give minus minus is not happening here. Let's give this level. Okay, let's give this level minus 2.5. So now this is 0, right? Okay, minus 2.5, this is 0, spacing is 2.5, insert above. Now it's okay. So this is base, this is my actually, this is my plinth level, and next will be my ground floor level here. I will do as SSL as I told you, and then this spacing will change. That is the spacing between the plinth level and the first slab. So it will be, we want to take this as 3 meters. So it will be 3, and then since they're going for ground floor only, and I'm taking 1 foot extra just in for my safety for them, I'm just doing this. And the slab thickness will go for 125 mm slab thickness here. Okay, 125 mm slab thickness, and this is okay. So once this is done, then we need to import the DXF file, which you need to prepare the DXF file. And in my full course, if you see, that is free on Udemy, and the link is given in the description. You can see that the particular, uh, how to prepare the TSD file. It is also given, and also the explanation for all the dead load and live load is also given. So I'll not do the explanation right now because it will be long video. I'm just doing it as a blog here. So first of all, you need to select the architectural grids. The unit will be in mm here, because I prepared the AutoCAD file in mm, and then I'll select only the center line, right? Only the center line I want, and then click on next, and then click on by layer and select all the levels, and click on finish. Then this will appear, and then I'll just import the XF, and again the TDT file which I should, and this time we'll cancel the center line only in mm and as shadow, and then click on finish, right? I'll zoom in with that my mouse cursor, and this is the thing. So this is the plan with the shadow. So the next thing which I need to do is prepare the columns here. Column. So column, let me prepare the column M20 grade concrete. Okay, and the size which I am going to give is 300 and 300. Seismic zone 5. So set the column this. Less is also passing in the software, but I want to. And I know 500 still is the most commonly used in the market nowadays. So obviously we'll give this. Nominal cover 40 mm for column is good, and all this is done. And after that, we'll just have this tick on automatic alignment. I'll just tick off and then click on save. Right. C 300 cross 300. This is the only size of column which I'll use. So there's no problem in that. And I'll just pick the column sheet. Right. So just take it from here, 300 to 300, and then do it like this, right? So since you see all the grids, so there is no problem in placing the columns. And the process is very easy. For the panning, you can just use the mouse middle button to pan. So the process is very easy. Let's see. I hope this is right because this I am selected. Group is C1, right? So group is C1, then it is okay. Okay, this group is C2. Okay, let me just section is 300 and 300, and everything seems all right. So I'll just delete it. Let me just delete it. So for deleting it, just select it and delete it, or else you can just go in 3D view and then click on this and delete it. Yeah, okay. And then I'll just apply it again. Select the column here, see 300, 300, and then just select this, like this. So in the 3D view, you can see rotate. You can just click the mouse right click and then just move around, and you can see the columns are ready. So now let's play the plinth beams. So we'll go to the plinth beam level, and we are already click on escape, and we are already on the plinth beam level. The base is the out plinth level. So we'll take the beam, the plinth beams, and we'll give a size of 500, and we'll give a size of 250 into 300. Let's try 250 into 300. And this is enough for the beam, right? 300, and here for the plane beam, save this beam. Okay, and set this PB 250 cross 300, right? So if there are secondary beam, so then the thing is different, will be different. Only one secondary beam here, but this will not be in the plane beam level. Actually, this will be in the next landing level. So there, the beam will join here straight. So there is no secondary beams actually. So everything will join. So just you can just click on here like this and join it. So it will be like this. So as you can see, this is the uh, beam here, and 300. So now once this is done, you can check the structure 3D, and this is the plinth beam which is ready. So the plinth beam, some people make a mistake. They, or rather, they, I can say it's the convention that they also put plates on here, or generally in normal residential building, the sand filling is done after that PCC is done. So don't no need to put any slab here unless there is no compacted earth below. So all the load go to the compacted earth, so no need of providing this slab. I'm talking of any software like Stat Pro, tabs, any software. You don't need to provide any slab in the base here. Okay, and this is the staircase portion, and then the staircase portion there will be only slab in the topmost headroom part, and there will be no other slab. Okay, so that's how we design, right? This is the common things. If you just have any experience of construction, you just get it. And we'll just go here and next to the next part, and for that we'll go into model and construction levels. So in next level is 1. Okay, just close this and go to the structure in the levels here. We'll double click on 1, and here we need to prepare the roof beams. Preparing the roof beams, just click on the beams, and here and just go here and just click here, new edit, 250 to 350. Okay, right? For the roof beam, we are going to give this minimum thing like and FE500 obviously. After just click on save, we'll just do RB for the roof beam 250 cross 350, right? And done. And for the roof beam portion, first of all, we're going to select this RB 250, and there is a secondary beam here because there will be a landing, so there will be a beam above this too. So like this will do, and like this also will do. So here, this particular beam, click on escape and this particular double click and go to releases, both the ends are pinned, make this as pinned, right? And here, this one is left and this one is right. Left one is pinned and right one has a column, so it is, fixed. So just check the supports, releases, fixed one and one is left, so it is pinned and this is fixed. Similarly, do this to same to this as well. And one on left side is pinned and right side or N2 is fixed. So all these details I had explained in my course. Just check out my course in the description. So free course, it's a free course, you still don't need to pay anything for it, right? And you will also get a certificate for it. Okay, so here and just join this like this, and after you join this, just check in the structure 3D, how is it looking. So it's looking okay, and then go back to structure 1 and go to slab on beams, and after clicking on slab on beams, two-way slab it is, everything is two-way here, 125 mm 20, everything is good. Just select this, and this portion obviously it will remain vacant, right? Check in the structure 3D, it will give you a feel of the structure, and after that you can just go and copy the same flow to the top level. For that you can go to construction levels, into just make this source as 1 and click on OK, right? As you can see easily it has been copied to the next flow, and then click on construction levels and make this as unique and then click on OK. So now it has become unique again. Just go to construction levels and check again, because this is a good habit to have. Sometimes you forget and then you create a mess. I also do, so that's why I'm telling. So like this, we have completed the construction levels. Now, most important thing which we shouldn't forget is the particular your headroom. So for the headroom, just make sure you have a level here. Generally, the headroom heights are taken as maximum. I'm taking maximum 9 feet, and then 8 feet is also okay for the headroom level. Okay, maximum if we just take is 9 feet. So if 9 feet means 9 divided by 3.28 is 2.74. Okay, so just take a level here, go to construction levels, and why not add a level here, insert a level above, and give a spacing of let's say 2.74 meters, and then just click on OK. And when you do so, just select all these 4 columns here, and topmost level, just make this as 8.74, right? Once you are done, go to topmost level which you've just created, just click on the beams, select the RB because you need the RB, right? And again, just first of all, just make the secondary beam, because like the point in making the secondary beams first is like, if you make the secondary beams first, single click and double click, then we will remember to just give the releases. Click on escape and then make the releases here, same as we had done earlier, because it's the same pin fixed. This also make this as pin fixed, and this both ends are pinned. So like this is done, and so this is done. Let's take the beam again and take the RB again and join this. And after that, we can get the slab here. Obviously, give a slab, two-way slab here. Here you can, this is actually a one-way slab, but it's a very small portion. So and two-way slab are not designed in Tekla anyway, so you can just give one-way two-way slab here, or if you want, if you just want, you can give a one-way slab here as well. I'll show you how to give a one-way slab. So for giving a one-way slab, what you need to do is you just need to go here and see two-way and just click on one-way here. And after clicking on one-way, okay, I changed this, so no, I don't want to change this. Just give two-way here, Yeah. Okay. I want to click insert a new slab, right? New slab. Select the slab is selected. New slab, and here I'll just select here one way, right? One way, like this, right? So this is a one-way slab which you created. This will not be designed, but it will take the load, all the loads which you are giving. So go to the structure 3D, click on escape, and this is our building model fairly. And next thing you can do is all the supports which you are seeing is select all the supports and select here supports and make them all as fixed, right? You can do that. And if you don't do that, there will not be much difference in the results from my experience. Select so, but you can do it anyway. So after that, when you are complete this with this steps, then you just need to apply the loads. So the loading will just go step by step. Let's go to the plinth level, which is a structure base. So in the structure base, first of all, let's just take the dead load first. So dead loads, all the loading by explanation I have done in my full course on Udemy, which is a free course which you can attend. Link is in the description. You watch that. For now, I'm just applying the dead loads. Go to load and take the dead load here, and after taking the dead load, take full UDL, and full UDL here. My calculation will be 7 for the half-inch wall. I'm taking the higher side that though, so I'll just apply it on all the places which I have wall. So this calculation and this load will be depend on your, this will depend on your wall thickness, length, and height available. All the explanation I've done. Check out my course, right? It's free for all of you. So in the 3D, just you can just take out the dead load here. So this is the dead load, how is it acting here? That's how the dead load is acting, and this is it. And in the next floor, we'll go and apply the dead load here. Okay, same. We'll just click on the dead. We'll click on full UDL. We'll click take care 7, and we'll apply it on all. Right. Don't need to apply between because there will not be any wall here between the staircase. So this is basically the load of the wall which is coming on the beam, right? And then we can take a level load. So this is a floor finish load, and floor finish load as per my experience from the IS code, and also a detailed explanation in the this lecture. If you take one, and this is sufficient, right, for all types of tiles, marbles, and all types of floor finish. So taking one here for the floor finish load, and go to the structure 3D, and you can check this dead load, right? And then go to the next level and just complete the dead load part. Go to the structure 2, right? And go to the structure 2, and in the structure 2 for the dead load, I'm taking this dead load first, full UDL, and first of all, I'm taking here, let's say 7 for the headroom portion, right? And then for the remaining parapet wall portion, I'm taking 3. This will be only along the periphery because the parapet wall is applied along the periphery, right? So, and after that, the floor finish load for the your roof. If the owner of the plot just intends to put some marble or some any material for the the roof, then I should consider that load as well, right? So I'm considering a dead load of 1 again. So 1 covers everything. So for the safer side, you can just go to this level load and take a floor finish load of 1. But generally, if you don't need to apply floor finish on the roof level, but I'm applying it anyway because nowadays people go for many decorative items. That's why I'm applying it, and just to cover the load and be on the safer side, right? So as an engineer, we should be always on the safer side, and also we should consider the economical aspect as well. Okay. So no, floor finish or dead load I'll apply here because this is the headroom portion. So I'll not apply any load here because it's not necessary. There is no wall or any type of floor finish here generally. So no need. So that's how, you need to, just think of the practical aspects, like, why you don't need to apply, slabs, here, because this is the, you have sand filling here. So those of you who have, some construction experience can relate to that. But, those of you who are only, just, working in the design field, they don't, they kind of tend to make those, mistakes, or that kind of make to tend to ignore these things. So these are very important things, because I also believe that as an engineer, you should, just be as well versed in design as inside. So both are important for me, right? Okay. And next part is the live load. And so, what does IS 875 part 2 just say, about this part 1 and part 2 say, dead load and live load. So part 2 is for the live load. So live load says that, live load code says that, for residential buildings in normal, areas, you can apply a live load of 2, and for the staircase and corridors, you can apply a live load of 3. So like, so there is only a small, corridor portion, if I can call it a corridor. There's literally no balcony or corridor here. So balcony and corridor, that is 3, and remaining is 1. So sorry, remaining is 2. So everywhere we'll apply 2 on these 2 floors, right? On this floor and this floor, right? So go to structure 1 first, and just select live here. Live is also called imposed. So just select this level load and apply level load of 2, and apply it here, and go to the next floor. Sorry, uh, go to the sorry, 2 floor, structure 2, this one. Just select this imposed, select the level load, and select the level load of let's say 2, and apply it here. And then we are ready with this live load side, right? Instead of live load, here imposed load. So we're ready. This is the imposed load. Since we don't have floor again, we don't need to apply, so no, don't have any slab here, don't need to apply imposed load here. So this is also one mistake you'll see people commonly do. So this is the thing. Now let's go to the next phase, which is obviously your design. So now the design phase, you'll see, simply go to design and simply click design on static. It will just actually be designed, but before that you need to apply the load combinations, right? You need to apply the load combinations. And if you are in an earthquake zone, obviously you are in some kind of earthquake zone. According to the zone, you have to design that to apply the earthquake loads and the load combinations. Wind design, you generally, for buildings less than 10-meter height, you don't need to apply any wind load. So you can ignore that. So only the earthquake load. So for the earthquake load, just you have this portion here, and you have this option of your loading. Just go to the seismic load, go to seismic wizard, and it's pretty simple. And I'll show you the simplest way possible to apply the earthquake load. I'm not going to that much complication, but not necessary. You just need to apply the load and check whether it's safe or not. Just no need to go into the details for now. When I'll teach the just theory part, then I'll go into very much detail. This is a plinth beam. So select the plinth. So select the plinth level. Don't need to go above below this. Zone, select your zone accordingly. I'm living in zone 5, where I'm constructing the building here. So it's in the northeast region of India. So it's just take this important factor of 1 for residential building, 1.2 for the next step, like for the apartments and all, and 1.5 where for very hospitals and other kinds of public buildings. So this is a residential building. So 1 zone factor and all, they take automatically. No need to think about that. I'm using your model response spectrum analysis always, because it gives on the safer side. And some people also question that you're using static analysis further and response spectrum for this. So it's no, there is no such foundation in that. You can use response spectrum for earthquake load. There is no problem. And by my experience in this software, right, if you use response spectrum, then there is less number of errors. So obviously, for the convenience, you want to use the procedure which gives you better results, right? And the details part about these two procedure, I'll explain in the theory part. And because when you are designing the, obviously you're having deadlines, right? You need to use the best method so that you can just give the results fast. So that's it. Then see moment testing frame without any masonry infills. And these are the type of buildings which you're having. So these are RC moment resisting frames without any masonry infill. This is what we only select. Okay. And next, and this type moment frame systems, and moment systems, and make sure you select this, RC building with special moment resisting frame, right? Always select this special moment resisting frame, right? Then click on next. Then just select this, all these loads, because they actually, if you just look into the codes of seismic load, they consider the dead load and live load and apply a factor on that. So everything you need to consider. Next, the detail part, the software takes care of that, so no need to worry. But if you are, just in the educational field or in the software development field, you need to know in the details as well. Operating part next, and then live load is there, so just click on next and then finish. So now you need to generate some load combinations. Go to load, and here you can see the seismic load is given here now. And next part is for the load combination. For the load combination, just go to combination here, click on generate, and select the operating here next, and then select all the loads combinations. I have IS code selected, so these are all, this can be different as per your code. So there is nothing special. Everything is okay. Next, click on next, click on finish, and then click on OK. Load combinations provided. Then most important thing, let's click on validate, and the structure is validated. You will just check. You can check whether the structure is validated or not. So once the structure is validated, the next thing which you can do is apply the load for the staircase. So now again, many people question why are not giving the landing and all. So here in this software, like in STAD and ATAS, maybe you can, I've seen that you can provide the landing as well by using some techniques. But here, when you are providing the staircase, you cannot provide the landing here. I have contacted the Tekla support as well. They have also given the same explanation. Also in the videos of Trimble, YouTube channel, if you see, they're also giving the same solution. Because so I conclude that from my the best of the knowledge that you can apply the load of the staircase here, but you cannot just apply the landing and then the staircase that much accurately. But you can apply the load of the staircase. So that's what I need. I need to apply my load of the staircase on my structure to see whether my structure is capable of taking that load or not. That's important. I don't, if I cannot model the landing and all exactly, I don't mind, because I only want to give the load and check whether the design which I have provided is safe or not, right? So don't worry about all these details. Go to model, okay, simply, and slab, click on flat slab. Here, one thing is very important, otherwise your results will never come. Just make this diaphragm as none, right? Make this, do this, take this 125, okay, doesn't matter, 125, you take it, and always start from the center, right? From the center. So center, how you know which is the center? This is a trick, right? So these are the bubbles you see. So this is the center bubble. So take it from here, and the staircase portion will go as far as up to here, right? So we'll rotate it and just take the center bubble very carefully. Take the center bubble, and then it's easy. Once you take the center, then it's easy, right? Like this corner, then this corner, and in this corner, just double click. This is your first slab, which is ready, right? See, just click on escape, and the next slab will be like this. Next slab is easy. Then once you make it one, right? The next one is easy. Just I made a mistake, right? That is a big mistake which I made actually. And I'll just select it and delete this. Basically, the staircases obviously will be on the middle level here, right? On the middle portion, mid portion here. So we need to make a level in between where you need to make room for the staircase portion, right? So we need to do it. For that, there is also a way here. So I'm glad we brought this up, because this is also a thing many people will just have some difficulty. So I'm glad we can approach it through this block, right? So simply go to frame, and just take this frame here like this, right? Once this frame is done, and go to this levels, and hopefully you'll just see a frame. Go to this frame like slide. So we can see these are the levels. So this frame is actually created here on this levels. As you can see, this is the foundation level, It is this bottom one is the foundation level. That's these are the next level. So this we know this is 3 meter. Just go this here, construction line parallel quick, not the this one. Just take this one, the construction lines, and select this. So once you just take this, just press F2 or function F2 depending on your system, and just click on 1.5. Set 1.5 and click on enter, right. So here also it will be actually the distance between these and this will be actually it will be 3 plus 1.5, which is actually 4.5, right. So just take all of this at once, 4.5 meter once, and then this is the next level. You don't need that next level, only 2 levels are there, right. Just click on escape, and we can put a slab beam here. Sorry, not slab. How can you put a slab here? 350 here. Just select this, double click here, and also select this, double click here. So this is done, and after that go to structure. Here you see this. This is done here like this. So you just go, just click. Actually, it's supposed to show here all the levels. I think if I close this, save this file and close this file, then it will come. Save this TSD file, and then close this file, then it will come. So I'll do that to just make sure all the levels are visible or not, right? So I closed and opened the file again. Levels are still not visible, so we'll have to just take some other way of actually let's see in the construction levels where these are visible. Construction levels, okay, they're not visible here. I think we can make from construction levels as well, right? In base, from base, let's take insert above here, and this one, this is 1.5, and from here also insert above, this is automatically 1.5, right? So this I think we can do, and click on OK, and now it should show here. Yeah, now it's showing. So just go to this base 1.1. Yeah, this is the level which you want, and here just take a beam and join it like this, right? Join it like this, and we know what to do with the support. Click on escape, double click, releases, pin, pin, and this is left pin, and right is fixed, right? Similarly, this one also, releases, left is pin and right is fixed. Right, it's done. And for the next one also, we'll do the same thing. That is, go to the next 1.1. First of all, go to beam, take the beam 350, B, select, double click, single click, single click, double click, escape, double click, releases, left pin, right fixed, double click, releases, left pin, right fixed, okay, escape, double click, releases, pin, and pin, both side pin. Now I think we are ready. Yes, now we are ready for providing the flat slab, right? Click the flat slab. Everything is okay. What I said, what I told you, it will be none, and thickness you can give as 125, or even 150 also you can give generally for the slab of the staircase. Click on save. I'll just save this as a staircase, right? Stair slab, right? Staircase is also a slab, right? Stair slab. Click on OK, right? Select the stair slab, and as I told you before, just take from the center, seeing the bubbles, and press it at the center of this. At the center of this, double click here. This one is done, and after that, take it from the center and take it here, and take it here, and then take it here, right? So since one level we are done, just click on escape. We'll use a smart way. Select this, control and select this. Click, go to edit, click on copy. Take this as the base point, right? Just simply, have I not selected the both of them? Okay, okay. Let me select this and control and select this, right? Both selected, then copy, then select this and then select this like this, right? Click on escape. So like this we have made the staircase here. Now the staircase we know, uh, can apply floor finish load first. Let's apply the floor finish load dead and go to your loading. Here we can apply the load through this area or slab. Let's go for the slab and floor finish load of 1 I'll apply. This is applied floor finish load of 1 like this, right? And for the live load, imposed load, I'll apply through slab load, right? A load of 3. As the IS code says that since the staircase and corridor, you can staircase, corridor, balcony, you can apply 3. So I'm applying 3. This is the maximum, right? I'm taking the safer side. So we have also modeled this, and you can just click on this validate option to see everything is okay or not. So if everything is green, everything is okay. And since you have just added some load, just make sure you do the seismic wizard once again. Same process will do once again because you've added some load, right? We don't want to, uh, just have any error due to this. Everything will be there. You don't need to change anything. Just run it again. Because from my experience, we do this. There are less chances of error, right? Same thing I'm doing. I'm just changing nothing. Again, same for the load combination. Since we have made some changes, just generate the load combination once again, right? Because in both the seismic and your load combination, there are some load combinations generated. So that's why, to be on the safer side, click on analyze, validate once again. Then when you're ready, simply go to design and just simply click design on static. Nothing to do. Software will take its time depending on your model and then model the structure. So sometimes this comes after designing everything. This comes now. Just I am also doing it for the first time. This particular model, and this is coming. So I'm glad this came actually, because many people have this kind of problem. Like whenever I solve, then always everything is okay. Then I don't think I will get a chance to tell you. But now client kind of glad that it happened. So what to do? How to solve this problem? Let's see. Let's find out. So let's see. So it's having a problem with rigid zones, right? So let's check first if the flat slab is rigid or it is none, right? Diaphragm is none. So we are good here. We're good here with the diaphragms. Now the next thing you need to check. Let's design a particular column individually. Design selection static. So it is okay. The design here. So what is structure not in equilibrium and this node failure and all, expand all. So this is telling this these things. Yeah, actually, this is the problem of the node failure in these zones. So actually, this showing problems here. Whenever I'm just applying this cantilever portion, for the cantilever portion, it is showing some problems. So let's try and solve this. It's the problem in the modeling the cantilever portion, because if you also follow, then you will also get the same problems, I guess. So it should now show in validate as well. Like validate is everything okay, and there's no failure here because is kind of the software is not kind of connecting this with this, so that's why it is having some problems in this portion. So let me just check it, and this is the problem when you are working stat and all. There is nodes are clearly visible, so generally don't get this node failure and all. There's a node here and it's at the center, so there is not much you can do about it. And this node is also at the center, right? also not do anything about it. In that case, I think what you need to do is, if this is software, like this is a software, right? If software cannot take everything, software is not considering this, then I think the best option is to, just make a beam at this level and ignore this, right? So what I'm going to do is I'm going to just, first of all, staircases, I'm going to select the staircases and delete this, right? That's what, what you need to make some adjustments. Glad, because these things it cannot show in tutorial or any course, but when you just work in practically, I want you to just use this software practically. You find this kind of things which really are problematic, right? So I don't think that there is any problem in this. Only this one there is problem. Click on OK. We cancel this, and for this portion as well, I'll just cancel this. Okay. Now let's see for this only these things. There is any problem. First of all, let me validate, and then go to design, and then go design on static. Let's see. Okay, now at least the columns are passing, right? This is a good sign. Let me just design this column as well, whether this is designed. Yeah, this is also getting designed. Okay, let me just check here all the columns here. Check selection static. Any beam, one beam. Let me see here. Check selection static. Any roof beam. Check selection static. Yeah, it's getting designed, right? Let me see the what is the reinforcement in the beam. Design selection static. It is passing 216 to 12, 216, 216, 216, 216, and 216, 216. So it's passing, and reinforcement is also pretty much economical, to be honest. So check selection static. So this is also kind of passing. 212, 212, 216. And this is also passing. So the all these members which are provided, these are quite safe. 212, 212, 212, 212. So there is no problem in that. And I think we won't provide this, right? We won't provide this. To 12. So this is, you are taking this directly. If we change down validation is outdated, okay, just go to model and click on validate. Validate is out, now it's okay. Design of static. Let's see what are the errors right now. Okay. So self weight excluding slabs. Why? Structure node and deflection. 9 nodes check structure is stable. Check contact support. Structure not in equilibrium. 3 nodes in structure not less stable. Dead load, structure not in equilibrium. 6 nodes exit deflection. So this is all, I think, this is due to this extra cantilever portion which I made. So I'll first of all just delete this cantilever portion first. So once you delete all the cantilever portion here, and here, and delete this, and maybe I'll expand it up to expand it in that level. Okay, I'll just delete this as well. This full, this also, this has a slab, right? Delete this slab first and delete this. Then click on validate. Then again, design on strategy. Okay, now problems are less, and as you can see, that all the errors are gone. Member may not be supported. Only this particular three members. Okay, which one? This one, right? And this one, and this one. These three members, they are only showing. So let's delete these three members. Right? Now let's apply them. Actually, if you want to take the cantilever, then some problem is coming. Actually, that then there some problem come when we are applying the cantilever also. So just simply go to model and simply just take this portion here and go to your structure one. We'll just give it another try, right? One more structure one, and we want to apply cantilever portion up to here, right? So what we'll do, let us just extend this here up to here and model, edit, copy this particular beam. Cannot copy, right? Go to model and just make a beam, right? Invite copy 50 to 350 to here, double click, escape, and take this node and give a node here, like this, right? Okay, now go to the structure and see we have done this, right? This thing. So let's see if this thing is working or not, or they're showing error. Click on validate, no error till now. Click on design and click on design with static. Let's see if there is showing an error. So go to model, go to general, and member intersection. Member may not be supported. So this is the problem which is showing this member and this member, right? The two members which are made right now. And member intersection is this one. So let's try if we can solve this. Otherwise, we'll just do away with the cantilever for now and still we find a solution to it. Because this is a very small cantilever portion. If you don't consider, then there is no problem. So this is the thing here. Member intersection is showing here. So let's see. I think I can get rid of the member intersection problem. Select the take the node and take it up to here, and click on validate, and click on design and design on static. I'm positive that member intersection problem will be solved. Right? Okay, member intersection problem is solved now. Only we have member may not maybe accidentally supported. So this is the problem which is showing. So let's try a different approach this time. Just let's try just taking a node up to this one up to here only. Okay, and this one also up to here only. This is the last try I'm making. So first of all, just click on validate and click on design. Let's see whether everything is okay or not. Design all static. So when you design everything is okay means all the problems were due to this, right? Then I'll take a go to your model, because this is the important step of learning the software, right? And take this one from here and another one from here, right? And after that, go to load and go to the through the generate the combination once again. Next, finish. Okay, and after that go to design on static, So I'm seeing that, okay, there is not any error which is showing till now. So I think we can give it like this, right? Okay, let me just, okay, now they are taking the entire thing at once. So there is a solution. You don't need to give any, this pinned and all. You don't give any pinned and all, they will take the entire beam at once. Here probably will the topmost portion will provide a, you know your flat slab. Okay, in this portion you don't need to provide anything. Just provide a, one way slab in the topmost portion. A flat, this beam I think we don't need to provide because this is very close together, right? So this is it. This is the solution, I guess. And let's do it for the next floor as well, because this is the thing we need to do, right? First of all, apply this beam up to this much, and then apply that, and then design, and then automatically it will take the full. So let's go to the next floor, which is structure 2. And in the structure 2 as well, do the same thing. That is, will apply, go to your model, will take the beam, take the your 2 beam, apply a beam here like this, and after that 2 more beams, right? 2 more beams, one from here to here, from here to here, and this is the last portion, or I think another one is remaining, right? Go to structure 3, go to structure 3, this also, this also. Just take a beam, select the beam like this, and take one from here, take one from here. Don't give any pin or anything. Do this, take one, and then after that, what you do, you just go to load, then go to combination and click on your generate. Next, 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 finish, and then click on OK. Okay, and after that, what you do, just click on escape, and after that go to structure maybe, and then go to design, then design all static. Once this is done, there is no error, as you can see. Okay, we have an error in the model again. Oh, no. What is the error this time? Shouldn't be an error because it wasn't, right? It wasn't earlier. Okay, no problem. We'll just delete this again, maybe. Let's try, because we keep trying. That's important. Go to model, go to beam, take the beam from here to here, 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 right? And then go to load, go to combination, generate the combination, next, 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 finish, click on OK, design, design all static. Still we have this errors in here. Okay, so now it is showing error in this portion, right? So whenever we apply cantilever, then there is a kind of problem which we are not able to deal right now. So we have tried, as you see, we have tried, not editing the video or anything. So because it's important that you know everything, what are the lacunas and everything in the software. But I think still it is a very good software, because there are many things which we can do. So once I figure this out, I'll definitely tell you if there is any solution to these problems, uh, making the cantilever part and all. There are some videos on the Trimble website as well. I'll also check that out and try to see how to solve this problem if possible. But it is actually a problem, and any structural engineer who designs, actually what happens is they don't rely on one software. They are using various software like ETABS and other software to analyze ANSYS, this MATLAB. They're using everything to do it. So in one software you don't get everything. This is very handy software for you know the in general things, right? So can blame the software. I think can do a lot of things here which you cannot do in other things, other software. So you have to appreciate this for that. Okay. Okay. So let's see, the loads are okay here. Dead load. Yeah, loads are okay. Post load. Yeah. So it is okay. Just let's apply the just click on escape and take the see the dead load, and this portion dead load is gone. So go to load, go to full UDL, click on 7, and I think this one I can apply it here like this. Yeah, remaining is okay. So next, what you do is just take the staircase portion, take the slab, and in the slab light, right? So not in the load, load in the model flat slab. Take the slab which you had created, and then take the middle portion. It's important why I'm not editing the video, because I want to know you, so that you can know the entire thing here. So okay, obviously it will not be like this. There will be a middle level, and we should just take at the middle level. So we have to give a beam at the middle level here. So let's go to the frame which we had created, I suppose. Uh, go to frame, and frame 9 will not work now, because you want another frame in 1. So click on frame and give a frame in 1. Okay. So then go to frame 1, and same process. Just take this parallel quick, not this one, this one, construction line, parallel quick. Okay, already it is there, right? In frame 1, already it is there. So okay, let me just do it again. I don't know whether it is frame 1 or frame 9. So F2 1.5 and 4.5, right? 4.5. So after doing this, click on escape and go to beams. Let's take 2 beam here. Double click, structure 3D. Let's see if I placed it properly. Yeah, it's okay. Let's go and click on validate for now. And first of all, let me see whether everything is okay, because go to load, take the combination, generate the combination once again. Everything is good. So now I think we can apply the staircase. We just go to none and apply the staircase here. Go to model, flat slab, take our saved slabs, stair slab, and middle, and then the middle, this, escape, and again flat slab, this middle, take this middle using the bubble here smartly, side. Okay, I think I messed up. Yeah, messed up. So I'll take again single, middle, end, and double click on this side. Escape, right? Select, and then okay. Then what you need to do? Go to edit, OP, do it. The loading part, as we've told, dead load. For the dead load, go to your model and go to what you call your dead load, and load, slab load, floor finish load of 1, apply, 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 apply. Live load of in the form of slab load of your 3 as per IS code. Apply, 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 and apply. Load, combination, generate, next, 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 finish. Okay, design, design on static. Okay, this time I forgot the diaphragms. Okay, so select and select, I think select all of them. So okay, now it's not coming. Just select one. Okay, select one of them. Diaphragm is none, right? So shouldn't be any problem. Rigid diaphragms, slab sloping is said to have a rigid diaphragm. Okay, okay, so you have to do it rigid diaphragm, right? That's what they're saying. Okay, okay. So make this as rigid diaphragm. Earlier, it was in the earlier versions of software, it would not take as rigid diaphragm. So that's why. So make this as rigid, right? Make this rigid. Make this rigid. Make this as rigid. Make this as rigid, right? And then validate. And then, sorry, go to design, design on static. Okay, it's saying that, okay, it's saying that we shouldn't give rigid diaphragm. I hadn't given rigid diaphragms, but why it is showing like this? I had given none first. Okay, okay, let me just try again. We keep on trying till we succeed. I just select all this, delete all this. So after that, go to model, go to flat slab, and here make sure you don't take this as rigid. 100 mm take this time, no problem. Select the center and select the center here like this. Center, select center, select center like this. And I want to give the load also here, so I can copy dead load. Dead load, go to load, slab load, load finish load of 1, apply, apply, live load, live load of 3, apply, apply, escape. So escape and then select this and select this. Go to edit, copy, all. Cancel and see whether loads are copied or not. Dead. Loads are not copied. So you go to load and slab load for 1 for the floor finish. And live 3. Go to your load combination, generate, next, 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 finish. Okay. Go to design, design on static. Now everything is okay. So this was a blog. You can see, like, whenever I make a tutorial, I make some edits. But this is a blog. You can see what are the problems which come, right? So there are many problems which will come. In the time of design, you have to solve those problems and finally you get results. Okay. So I recommend that if you want to know more about the software, just take my course, which is available on Udemy. And after that I'll just keep posting on various course videos and blogs, so that all these problems which you also face while solving in PhD can be solved. And also I'll try to make videos on other software as well. So stay tuned, and if you have any queries, just comment in the video. If I can solve them, I'll definitely try and make a video on that. Okay, bye bye.